to the cloud. Good, thanks. Hi, everyone. Good afternoon, good morning. It's great pleasure we have Zifu Wang joining us to give a talk about his research. Zifu is currently a PhD student at George Mason University, working with Professor Phil Yang. And today he will talk about large language models, RAG, and their applications in some ocean data science. I first met Zifu, I think it was in 2022 in the ESIP meeting at Pittsburgh. And then just a few weeks ago, we met again in the AGO 2024 conference, and then we share a lot of those common interests in large language models, semantics, and application in data science. So I invited him to give a talk in the Semantic Tech webinar. So thanks a lot, Zifu, for your time. Next, I will just give the floor to you for your talk.
Thank you, Dr. Ma. Yeah, my name is Zifu Wang. I'm from George Mason University and PhD candidate. This project is, I'm doing the research project with the ReadyMinds. We are focusing on implementing RAG to minimize LLM hallucination in source-based question answering. So we are specifically focused on the ocean studies over here. In this project, I'll first have an introduction and the objective, methodologies, and results, and give out some future directions. Large language model actually has innovated the way that we do research. We could utilize it to rephrase our languages, especially for us like non-native speakers, and also help us draft or debug code. For example, when I have the problem of drafting in the initial version or some need to debug the code, I utilize large language model a lot, and then also help us to find quick answers toward unfamiliar domains. For example, I'm not an expert in ocean knowledge at first, so I actually study a lot by searching in the large language model by finding the initial result so that I can keep doing other researches. However, the large language model answers with hallucinations, especially with very detailed questions. When there are questions, it comes to the question it doesn't know, it generates random answers that do not make sense. One quick example would be like if I say, I ask the large language model to list me an example of illegal fishery that has been sued in the court. It probably will create some random person with random cases in random years. And the source link it provided would be not usable. I think most of the people here probably has tried to use large language model also to find the scientific sources for paper references. But those references it gives out either does not even exist or the source is not even related to what we're searched. So in order to make the model smart enough, one way is to fine-tuning it by our collected domain-specific data, but it actually costs a lot. If we use GPT-4o as an example for fine-tuning, if we want to fine-tune like 100,000 papers, and assuming each paper has around like 8,000 words, each epoch will cost around $26,000. And we know that probably one epoch fine-tuning is not enough. We probably need several rounds of fine-tuning, which means that will increase the cost even higher. Additionally, if we want to add more data later, we might have to retrain again with many more epochs. So that brings the objective of this research. So first, we want to collect the ocean-related knowledge from different source types. And then we want to develop a large language model that answers with less hallucination by providing reliable source citations. And lastly, we want to balance the cost of tuning a model when adding new knowledges. In order to achieve that, we first come out to the data curation process. So during the data curation process, we explored the paper and articles from scientific community and also news media and the local community and knowledges. And also there are some policy documentations as well. So currently our focus is on ocean studies. Specifically, it is on marine protected area, fishery, deep sea mining, ocean bio prospecting, and marine bioprospecting. We implemented the Google Cloud Platform to construct a PostgreSQL database after the data curation. The metadata of each article and the documents are extracted during the data curation. It covers document itself and also author information, and also the geographic details and also the institutions. So at this moment, we have only collected open source paper and news articles and policy documentations, and then they are all from open source archive. So after all metadata is collected, we built up the vector database on Google Cloud Platform. We used its Vertex AI embedding model to convert the content of the article into vectors and implement the PG vector data on PostgreSQL to store all converted vectors so that all articles content itself and their embedded vectors are stored in the same database. After the database is built, the RAG is implemented to find the most relevant articles or documents by doing similarity search, which is the core over here. In our system, when first user input their queries to the system, we first revise the prompt based on the filter they selected, and also the I don't know why the line over here disappeared. There should be another line connected over here. Let me see. Oh, over here. My bad. Yeah. So when the user send out their queries to the system, we first prompt tuning the user's query by considering its filter. So this filter actually has the information about year, geographical location focus, and either it's open source documentation or what perspective knowledge you want to focus. And then after we have the user filter and also the user query combined together, we send the large language model embedding. And by doing this embedding, we'll commit the similarity search with the database we have built it before. So in this database, we have the author's date and also geographic locations and many other informations over there. So this filter will be applied to both the database and also the prompt. After the similarity search was done, we'll retrieve the relevant sources. After the sources got retrieved, we can specify how many data we want to retrieve over here, and this data we will use to rank and also reduce. After we have all those information, we'll pass out to the base model we have of the large language model base model we have, and then we combine them together to generate the answer. So over here, this is one of the result that I was using ChatGPT as a base model and the ChatGPT-4 with the RAG. I'm asking, I want to get up to speed on deep sea mining and summarize the current scientific perspective on its risks, opportunities, and answer me with 5 source links with further ratings. Geographic focus query is Indonesia, and please find the relevant case study. Practical implementation field study, including an overview of relevance case study on practical example present in the context. So over here, when the ChatGPT-4 give the answers over here, it actually considering opportunities and risks. But in case study over here, it actually gives some bad links. So for example, for the further reading of the deep sea mining, especially focused on Indonesia and its implementation, there are some source links. But if I click it, it actually just pop me out to some kinds, just a website. I can click it right now probably. And then you will just send me to here, and I don't know where this, I don't know where this is. And also same as those links too. Yeah. So those links are actually not working well. However, considering the ChatGPT-4 with the RAG implementation that we have implemented into the database, that when we click the source one over here, you actually leave me a real paper that's actually studying the deep sea mining on the Indonesia. And there are some corresponding PDF that we can download as well. Same to those links. All those links are usable. And one of the quick demo I want to do over here when showing the result. Let me exit. Yeah, you guys see my screen here. I'm accessing another computer here. So this is running my locally. As you can see, I'm in this project. I can select all date, and also I can select in which year. For example, I can say I only need the source in 2024, and I want the scientific source, and only and include both scientific and non-scientific, basically indigenous data and also policy documentations. And also I can include the open access papers over here, and I want to see that I want to focus on I would say just Indonesia over here. Kind of slow. The internet is kind of slow because I'm sort of, let me reconnect. I think I lost the connection over here. Give me 1 second. I think the computer. Yeah, I think the computer lost its connection. Sorry about that. Yeah, I typed Indonesia and I prioritize the case study. And I want to ask question, which is about, I just showed it over here. So every time I ask a question with the same question, you will answer differently. So what I showed in my PowerPoint, which is over here, it's actually different. Will be different than what I showed here, but they will be similar, and those sources will definitely usable. And this time, as you can see, the runtime over here is pretty slow because it's actually going through the all database by doing the similarity search. Currently in our database, there are around 20,000 articles inside of the database. They are all focused on the deep sea mining, illegal fishery, and other ocean study perspectives. And right now we are going to add more data into it so that we can have we can answer more detailed question to different domains. As you can see, all those source over here actually is clickable, and the one source is actually referenced to. It will have some journals that was used. It will show what journal used, and also as you can see, all those journal has the right publication. It's all in 2024, so it's not using some it's trying to use its newest data over here. Yeah. And if we search the same question in the ChatGPT right now, as I showed it in my PowerPoint, actually, it will give the relatively not hallucinated answer over there. All right, I'll go back to my slide. So there are some future directions that I want to share with the community as well. So the next step, we want to improve the answer quality. As you guys can see over there in the current prototype, the answer over here, I think they are not still not detailed enough. Although they can correctly cite the paper with a specific case study, but we think there are improvement which need more human expert to verify it. And next is improving the react time. And also you can see there when I do the demo, it takes around like 1 or 2 minutes to finish generating all the answers. And lastly, we want to have the source ranking by its relevances instead of by our human filters over there. And that's all my presentation. Thank you very much.
Thanks a lot, Zifu. That's absolutely very impressive work. Yeah, next we do have a lot of time for comments, questions, and discussing.
So can I start with a quick question?
Yeah, sure.
So Zifu, I see you presented very impressive work in general model and RAG works, and I'm wondering that when you ask a specific question about ocean articles, but what if the question is not addressable or not included in your existing database? How would the large language model reply?
You will say, I don't know. You will say, based on the context in the database, I do not know. So I think that's one of the best thing what we have over here. Since when it's trying to find out the sources if it doesn't exist. For example, I'm asking, what's the relationship between Romeo and Juliet in this kind of situation? You will try to find out, try to first convert this query into vectors, and then doing a similarity search in the database, and you find nothing, and it will tell you, based on the provided context, you will we do not know. But from our own knowledge, you will do something like I can tell you what's the relationship between your Romeo and Juliet is.
Oh, that's very interesting. But according to my knowledge, I believe large language models are trained to answer or try to respond to the request as much as possible. So anyway, they will try to find some relevant materials for you to say, maybe you can find answers from these articles. So did you make any, say, distance threshold for your vector similarity comparing, or do you apply any other strategies to set the boundary of unknown?
So the similarity search algorithm we're using currently, there are basically two. One is cosine similarity, one is Euclidean similarity distance. So based on those two, I did not set up any boundaries, but I think that's a very good way that we set up a threshold of comparing the similarity. If the similarity is less than certain points, we just directly ask the large language model to say, okay, this is not relevant at all. This does not make sense. So I cannot answer this question. I don't know. Yeah, I think that's a very good point.
Okay, thank you.
Yeah, I can probably show you if I ask the question which is not completely unrelated to the ocean study I'm testing right now. I can show you later when it's giving the result.
Okay, good to know. I think I'm good.
Yeah, thanks, Jing and Zifu, for the discussing. Do we have any other comments, questions from the audience? Yeah, Rob?
Yeah, thank you. It was a good presentation. On your first point with future directions, the act of improving the answer quality, what are the kinds of feedback patterns that you envision will be useful for feeding back into the system? So the RAG process is largely unsupervised, but I believe you're talking about a bit of a supervised or peer review process for enhancing kind of the response database. So what does that pattern look like?
I don't quite get your question. So you are saying that in order to improve the answer quality, what approach we're giving out right now, or?
Yeah, what would be the approach of feedback? Is it just a rating system, or is there something more I don't know, free form feedback? Because you're asking the human to go in and sort of train a complex system that you don't have a lot of transparency on. So there must be some sort of more natural response that gets coded into the system that indicates whether an answer is actually of good quality. And the answers, of course, are generated. So you're talking about a gazillion variations of generated responses. How does that all kind of work back into a cogent database?
So currently there are two approaches I can think of right now. First is that after we get the response from the real human expert about oceans, for example, deep sea mining or illegal fishery, we after they provided the what the weakness of the answer, we will either going to do the prompt tuning, so basically ask the large language model to focus on this perspective a little bit more, or another way is trying to improve the data quality by itself. So in this prompt tuning, in this RAG process, we still have to encounter the issue of token problem. So it cannot fully read the whole paper. For if a paper has like 8,000 words, if it read, or like if, for example, if I ask for 5 articles for references, you will read like 40,000 of the words. So in that case, we have to actually first summarize it to certain points, and then ask the large language model based on this summarization. And I think on this point over here, we have to do a better job on finding the good or better data by when we try to summarize the articles there. For not just asking for summarize, but also probably do more data extraction inside of the literature itself to find the most relevant answer. And then based on that documents, based on that information, we provide the answer. I think that's another step we're actually thinking about right now.
Thank you.
Good. Yeah, thanks. Yeah, I do have a really simple follow-up question, but Zifu, like when you do the question answering, you showed us the links, URLs to like source literature or database. For all those literature or database involved in the question answering process, do you need to like collect those literature and the database by yourself, just to like set up a boundary for the question answering?
Yes, actually, the reason why we are set up this database is because some paper over here, they are all on the website. They are all PDFs. So directly reading from the website, we need a web scraper. Those web scraper on different journals has different different setup. So one scraper is not possible to include all the data. So we actually have to download the PDF and extract the PDF content one by one, and then get all the content into the database by ourselves. So that actually sets up the boundary. If there is one article which is very good, recently published, but it's not in our database, we will not considering that because it's not in our database. So that's kind of the limitation, one of the limitation of this at this point right now. But a good thing is that if there are some literatures you won't include. You can just directly input that into the database, and then without retraining it again. Because as I mentioned, if you want to add, for example, you want to add a new direction of research, for example, the ocean creatures, not just illegal fishery, not just deep sea mining, but ocean creatures like whales or sharks, those kind of studies. Then you just need to get more data and the input into the database, and you don't have to retrain it anymore. So that kind of reduce the cost of fine tuning too.
Okay. Thanks. We still have time. Do you have any other comments or questions?
I think I can show.
Oh, another question answering.
Yeah, that question just asked over there.
Yep. Mm-hmm.
I was asking, what's the relationship between Romeo and Juliet over here? And then he says, apologize for any confusion, but your question about the relationship is not alleged with retrieved. The context provided. So you will tell you that I don't know. Yeah.
Okay. That's good. Okay. Thanks a lot, Zifu. If there's no more questions or comments from the audience, we probably can end here. Thanks again, Zifu, for this wonderful talk. And just a short announcement. We will soon have the ESIP January meeting in 1 or 2 weeks. Zifu will give a follow-up talk in a session organized by the Semantic Web Technology Committee. And Jean and another student will also give talks about large language models and the neuro-symbolic AI applications in that session. So if you want to know more details about Zifu's work, please follow the agenda and schedule of the January meeting and find his talk in the agenda. Thanks again, Zifu.
Thank you very much.
Wei Ling, can you help stop recording?
Yeah.